Hello YouTube. This is A_Hypertruck again, and this video is just a quick update on what I've been doing the past year. So, the past year, 2022, I didn't really stick to my original 16-bit CPU plans. Now I'm actually deciding, and I will explain this in a future video when I'm completed. I'm actually done a bunch of other research working on seeing on what other people have done, and I've finally concluded that the ultimate goal for me is to create an 8-bit CPU with similar to Maneater's except with more enhanced capabilities. I'll send references later on once I'm finished, but for now, just to get you guys, if you're ever watching this, a little bit of insight of what I've been doing in the past year. I've decided to continue to breadboard format and make a breadboard computer. A major difference than the Maneater computer that I wanted to make was an expanded ALU, so I could do have a large instruction set and just be able to do more things with the computer, and just really upscale every single component. So, for example, I wanted more registers. Here are still 8-bit registers, and something that I wanted was a larger memory. So here I've already mapped out a plan for expanded 16-bit memory address, and then of course that would mean expanding the program counter, which I have up here, and I wanted to add additional stack pointer so I can make like functions inside software. And since I'm using a 16-bit address line, I'm going to have to create a 16-bit bus, and what I've decided is to just have a separate bus line over here. These are what these wires are for over here. And there's what I would call like a transfer register or a new address register. Register 16-bit 16-bit register, and all these are 16-bit registers, and it's just going to be connected to, as you can see, I've made a space over here for adding the 8-bit bus line. And then some other things I have here. Here's a test ALU that I'm planning to make. It's a special chip. It's the 74LS 181N. I'm planning on using that. And for like I/O, user input and output, I'm still planning on adding a 7-segment display for like 8-bit signals, but ultimately I really want to add an LCD screen, and I've seen a lot of people on YouTube who have put those onto their breadboard computers, so I've made this little test module to see how everything works. And also, a thing I saw online was someone actually added a PS2 keyboard, because I know USB, like the signal is a little bit more advanced, and PS2 is only like a clock line and a data line. That's pretty much it. So it's really simple, and I've got like this Arduino Nano right here to test things out. So here's like a small module that I've made to work out the PS2 signal, and that's pretty much it. A short demonstration. Let me put down the camera and plug in this unit. So as you can see, it's a little bit on. Let me just turn off these counters here. So I've also labeled everything here, so it's easy to understand. That's inverted signal. So what I've had set up here is that the transfer register actually only takes an input from the 8-bit bus. So here I have some wires to do a test input, and what I'm going to do is actually lower down the clock signal. And this is just a Maneater basic 555 timer. Sorry about that, but the camera just turned off for some reason. I'm not too sure why. Anyways, this is the same Maneater design, so I'm able to adjust the clock. Just going to put it real slow for now, and then actually I'm going to stop the clock, and then what we're going to do is load these values in. Nice and neat. And then I'm going to, let's see, yes, it's this one. Just demonstrate some capabilities. It's able to load that baby on there. And, oh, don't want to do that. Continue outputting onto 16-bit bus. And click here. There we go. And as stack pointer, you have to be able to go up and down. I will explain all these in a future video, but this is just a basic understanding. So over here, if you can see, low is gonna be up and then high is gonna be down. So I'll just demonstrate that here. So I have it set on low, and if I want to put on set the count enable, it's gonna actually count up like just the normal counter. Just so, and then I can actually switch the direction like this, and then it will count in reverse. Yep. Okay, and then if I were to, actually I want to set this count enable to low to enable it, and then we can actually reset this program counter right here, so all the values are gone. But if we just want to set everything back up, let's go like this, and like that, everything is back on from the transfer address, because right now we're outputting it onto the 16-bit bus. And then we can enable the count here, and as you can see, a bunch of the LEDs are pretty unstable. Like overall right now I've got around 200 wires already over here, was roaming about, and there's some electrical interferences that's messing up the signal. So I will need to add a bunch of controls over here to help stabilize the signal. As you can see, also the clock, when it runs, is going to be unstable, but for now it's pretty small, so it does work. Okay, as you can see, like this, and if I turn up the clock, it's gonna run at full speed. Just like that. The stack pointer is counting up. The stack pointer is counting down, and the program counter is counting up. And I have tested everything in the register, these registers. I think I'm gonna work on a 4, like ABCD register, so 4 registers I have tested out with all this small bus system I've set up. These wires, and I'm pretty sure they work. See you in the next video.